Welcome to Two Projects. In this video, we are going to explain the project Achievability Approximation of IDS Hub using Collaborative Network Model with Machine Learning. Introduction. In the face of escalating cyber threats, the need for advanced intrusion detection becomes crucial. This project delves into the complex task of identifying and preventing sophisticated cyber intrusions, aiming to fortify network security against evolving challenges. Leveraging the capabilities of machine learning and deep learning, the project is dedicated to strengthening intrusion detection systems. The primary focus lies in developing adaptive models that can surpass the limitations posed by traditional approaches in the dynamic landscape of real world cybersecurity. Tailored for a diverse audience, including cybersecurity professionals, IT personnel, and organizations, the project aims to provide valuable tools. These tools empower users to not only detect but also effectively mitigate network intrusions, ensuring a secure digital environment for all stakeholders. And by utilizing the KDD Cup dataset, the project's insights are not confined to theoretical scenarios but contribute practically to the field. The outcomes aspire to elevate the effectiveness of intrusion detection in tackling the contemporary challenges posed by ever evolving cybersecurity threats. Objective of the project. So, as I mentioned earlier, the project aims to address cybersecurity challenges by enhancing intrusion detection. It focuses on developing adaptive solutions to identify and counter evolving network threats, contributing to robust network security measures. And we aim to conduct a thorough investigation into network intrusion detection using machine learning and deep learning techniques. Specifically, leverage the KDD Cup 1999 dataset to gain profound insights into the efficacy of various methodologies for identifying and countering network intrusions. And the objective also includes to assess and compare the performance of a diverse set of models, including autoencoder DNN, decision tree, random forest, KNN, and extra tree classifier. The aim is to comprehensively evaluate their accuracies, providing a nuanced understanding of their capabilities in the context of network intrusion detection. Requirements needed to execute this project are software requirements. Software needed is Anaconda, primary language used is Python, front-end framework used is Flask, back-end framework used is Jupyter Notebook, database used is SQLite 3, and front-end technologies used are HTML, CSS, JavaScript, and Bootstrap 4. Hardware requirements needed are operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Now we'll discuss the working models of flow of work. So the first step is importing required packages. So this step involves importing essential packages like NumPy, Pandas, sklearn, TensorFlow, Keras, Seaborn, and Matplotlib to establish a robust development environment. These packages facilitate data processing, machine learning, and visualization tasks. The second step is exploring the dataset. So here we utilize the KDD Cup dataset for comprehensive analysis. Dataset exploration involves understanding its structure, features, and patterns, providing foundational insights for subsequent processing and modeling steps. The third step is data processing. In this step, we leverage Pandas and Keras data frames for efficient data manipulation. This includes dropping unnecessary columns to streamline the dataset for analysis, ensuring that only relevant information is retained. The next step is visualization using Seaborn and Matplotlib. So this step includes utilizing Seaborn and Matplotlib for data visualization, creating graphical representations of the dataset's characteristics. Visualization aids in understanding patterns, distributions, and potential correlations, guiding subsequent modeling decisions. The next step is label encoding using label encoder. So here we apply label encoding to convert categorical data into a format suitable for machine learning models. This step ensures compatibility with algorithms that require numerical inputs. The next step is feature selection. So in this step, we employ select percentile with mutual information to perform feature selection, identifying the most informative features for model training. This optimization enhances model efficiency by focusing on relevant attributes. The next step is train and test split. Here, we split the dataset into training and testing sets, preparing it for both deep learning and machine learning models. This step ensures an unbiased evaluation of model performance on unseen data. The next step is training and building the model. So here we implement various models including auto-encoder DNN, decision tree, random forest, KNN, and extra tree classifier. Each model is trained on the dataset to capture patterns and relationships, contributing to a diverse set of predictive capabilities. And in the next step, as an extension, we introduce a hybrid model that combines predictions from multiple individual models, enhancing overall accuracy and robustness. Additionally, a user friendly Flask based frontend with authentication was developed. The next step is Flask framework with SQLite for sign up and sign in. So, in this step, we integrate user registration and login functionalities into the Flask framework. Users can sign up by providing their information, and subsequently, they can securely log in using their credentials. This enhances system security and allows for personalized user experiences. So, after signing in, users provide input through the front end interface. The input data is pre-processed to prepare it for prediction by the trained models. This processing step ensures that user-provided data is in a suitable format for the model. And the pre-processed user input is fed into the trained model for prediction. The best performing model is selected to make predictions based on the input data. And the predicted outcome is displayed through the front-end interface, allowing the user to view the results of the model's predictions or analysis. Now we'll understand about the algorithms used. So the first algorithm built is auto-encoder DNN. So auto-encoder deep neural network, that is DNN, is an unsupervised learning algorithm employed for feature learning and extraction. It uses a neural network architecture to encode input data into a compressed representation capturing essential features. In this project, auto-encoder DNN is valuable for learning intricate patterns in network intrusion data, aiding in the detection of subtle anomalies that might signify cyber threats. The next algorithm built is DNN, that is Deep Neural Network. So, Deep Neural Network, that is DNN, is a versatile supervised learning algorithm with multiple layers. It excels in capturing complex relationships within data. In this project, DNN serves as a powerful classifier capable of discerning intricate patterns indicative of network intrusions. Its depth enables it to learn hierarchical representations for robust prediction. The next one is decision tree. So decision tree is a tree-like model where each internal node represents a decision based on input features. It is adept at handling categorical and numerical data, making it suitable for this project. Decision trees offer interpretability, making it easier to understand the decision-making process in network intrusion detection. The next one is random forest. So, random forest is an ensemble learning method that constructs multiple decision trees and merges their outputs. It excels in mitigating overfitting and enhancing generalization. In this project, random forest combines the strengths of individual trees, providing a robust and accurate framework for intrusion detection. The next algorithm used is KNN, that is K nearest neighbors. So KNN is a simple yet effective algorithm that classifies data points based on the majority class of their neighbors. Its adaptability to various data distributions makes it suitable for this project. KNN is valuable for detecting local anomalies in network traffic patterns. And the last algorithm built is extra tree classifier. So the extra tree classifier is an extension of random forest that further randomizes the tree building process. It excels in feature selection and reduces the risk of overfitting. In this project, the extra tree classifier contributes to a diverse ensemble, enhancing the overall accuracy and robustness of the intrusion detection system. Now we'll see the comparison graphs. So this is the horizontal bar graph comparing accuracies of different algorithms. In this graph on x-axis I have accuracy scores and on y-axis I have algorithm names. So accuracy measures the overall correctness of predictions, showing the percentage of correctly classified instances. This is precision scores comparison graph. In this graph on x-axis I have precision scores and on y-axis I have algorithm names. So precision measures the accuracy of positive predictions, indicating how many predicted positives were actually correct. This is recall scores comparison graph. In this graph on x-axis I have recall scores and on y-axis I have algorithm names. So recall measures the ability to identify all relevant instances, showing how many actual positives were correctly predicted. And this is F1 scores comparison graph. In this graph on x-axis I have F1 scores and on y-axis I have algorithm names. So F1 score combines precision and recall into a single metric, balancing accuracy and completeness in predictions. So the algorithm which is best performing in all the performance metrics will be used for predictions. Execution of the project. To execute this project, first we need to open the code folder which contains the project source code files. So this is KDD cup folder in which I have KDD cup intrusion dataset on which we will train the models. This is static folder. This folder consists of files related to CSS, JavaScript and Bootstrap. This is templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML pages. This is model file which contains algorithm information. This file will be loaded into the project code during runtime to utilize the trained models. This is notebook Jupyter source file. So this file contains a combination of code, graphs and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. This is signup.db file. This file is the database file used to store user information. So now copy the path of the code folder from the address bar of the file explorer. I'm copying it. Open Anaconda prompt. So use the command cd followed by a space and paste the copied path and hit the enter button. So this command is used to change the current directory to the code folder's path. So now compile the app.py file using the command python space app.py. I'm typing python space app.py and hit the enter button. So this command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, localhost, and port unless configured differently. Now copy the local link provided by the framework. I'm copying it and paste it into any web browser. I prefer Chrome. After pasting it, hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Flask framework. So here we can see a sign up link, click on it. So if you are new users, we have to register first. Fill in all these details and click on register button to sign up. And if we already have an account, we can directly log in by clicking on this link. So as I already have an account, I'm clicking on this link. So here we have to provide our credentials, username and password and click on login button. So it has redirected us to the classification page. So now we have to fill in these parameters and click on predict button to get the detections. So first we'll understand these parameters. So the first one is protocol type. So it identifies the network protocol used in the data such as TCP or UDP. Service specifies the network service being accessed or utilized. SRC bytes represents the number of bytes sent from the source. DST bytes represents the number of bytes received at the destination. Logged in indicates whether a user is logged into the system. Count refers to the number of connections to the same host. SRV count represents the number of connections to the same service. SRV different host rate calculates the rate of connections to different hosts for the same service. DST host count counts the number of connections to the same destination host. DST host SRV count counts the number of connections to the same destination host and service. DST host same SRV rate calculates the rate of connections to the same service on the destination host. DST host different SRV rate calculates the rate of connections to different services on the destination host. DST host same SRC port rate calculates the rate of connections from the same source port to the same destination port on the destination host. And DST host SR with different host rate calculates the rate of connections to the same destination host but from different source hosts and services. So now we'll fill in these parameters. So I have entered the parameters. Now click on predict button. So here we can see the outcome, that is there is an no attack detected. It is normal. So we'll try again. Click on home link. We'll try giving another set of parameters. So I have entered the values. Now click on predict button. So here we can see the result, that is there is an attack detected and attack type is DDoS. So similarly we can give any set of parameters and can get the detections. So we can get the detections as normal, DDoS, probe, U2R and R2L. Click on home link, we'll try again. I have entered the values. Now click on predict button. So this type, the attack type is U2R. Now click on sign out. So the conclusion here is the project rigorously evaluated diverse machine learning and deep learning models including auto-encoder DNN, decision tree, random forest KNN and extra tree classifier. This extensive evaluation provides a nuanced understanding of the performance in network intrusion detection. The integration of a hybrid model combining predictions from multiple individual models demonstrated enhanced accuracy and robustness. This synergistic approach contributes to more reliable and accurate predictions, crucial for effective network security. The development of a user-friendly front-end using Flask framework with SQLite integration ensures a seamless and secure interaction. Users can input feature values, observe real-time predictions, and gain valuable insights into network intrusion detection through an intuitive interface. And by leveraging advanced feature selection methods such as select percentile with mutual information contributed to the creation of streamlined models. This ensures that the models focus on the most informative features, optimizing efficiency and accuracy in intrusion detection. And the project's use of the KDD Cup dataset and evaluation against real world intrusion scenarios underscores its practical relevance. The insights gained and the models developed have the potential to significantly impact and strengthen real world network security systems.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.